and welcome to episode 4 of Project Milano. Things have been pretty crazy around here since the last episode. There's been a lot of exciting things going on behind the scenes, but don't worry, it's all good and all modelling related. I'll put out an update soon explaining what's going on, but rest assured I'll still be building the projects you follow and enjoy. Okay, let's briefly recap where we left off many months ago. I decided to recreate a model of Milano from Guardians of the Galaxy in 1:48 scale. This would result in a model with a wingspan of about a metre. I designed from scratch the cockpit interior of the Milano, based on some basic drawings and a lot of movie screenshots. These CAD files were then broken down into components, which could then be 3D printed. This was a really difficult phase of the build, and given the lack of information and complexity, it was doing my head in. Getting the 3D prints completed and fitting together well was a major milestone. At least I had something physical to show for my weeks spent in the CAD software. I needed a break away from Milano, and figured that a quick and simple build would be just what I needed. So along came the APC from Aliens. It ticked the simple box, but it wasn't quick, in any sense. For me though, it was the right medicine at the right time, and I'm glad I took it. It seems you guys liked it too, as the series has been incredibly popular. As a consequence of the APC build, I've had a lot of attention from organisations wanting to support the channel. Elegoo reached out and offered me a printer, and as I hadn't tried one of theirs before, I asked for the new Jupiter SE. This is their biggest printer, and is designed to compete with Anycubic M3 Max, which I also have. They released the Jupiter a while back, and this SE version replaces it. All of my builds are big, and I need big printers. I figured this would be ideal for the Milano, so I'll be using it as much as I can on this build. A few days later, and it arrived. It comes as you'd expect, incredibly well packed and is a real heavyweight. 5 years ago I bought my first resin printer, a photocentric Precision 1.5. You can see it in episode 9 of my vlog. The Jupiter SE is roughly the same size, a third of the price, and has 10 times the build volume. Technology is moving so fast. The build volume was the most important feature for me. It's 278 by 156 by 300mm tall, which is huge for a resin printer. The printer comes with everything you need to get set up and running. You just need the resin. It has an interchangeable air filter and a resin feed pump to keep the resin topped up at all times. The instructions are clear and easy to follow. It's just the same as a smaller printer to set up, just the parts are bigger. The build plate is massive, as you'd expect, and it comes with a raised pattern to help get that all-important first layer to stick. This little device is for the resin feed pump. It's easy to install, but you don't have to use it for printing if you don't want to. I'm normally checking my printer every few hours with excitement, so I'm always on hand to manually top up the vat. These are the probes that go into the resin bottle to draw off the resin on demand. Of course you get a box of gubbins with all the usual tools, filters, scrapers, USB drive and a plug-in filter. As you'd expect, the vat is huge. It's well designed with a pouring spout, but will be a real handful trying to empty it by hand. Fortunately, Elegoo have a system set up that will allow the feed pump to drain the resin back into the bottle from the vat, should you need to do so. Very clever. There's a hole blocked off in the cover if you want to set up an external extractor, and a cutout for the feed pump. The power input, on-off switch and USB socket are all on the right-hand side of the printer. At the back there's 2 massive cooling fans. There are plug covers for the resin feeder and filter in case you don't fit them. The cover is one piece and has to be lifted off vertically, which means you need space above the printer. And here it is with the filter and pump installed. The protective film is peeled away from the underside of the vat. Another protector is also removed from the screen. The vat locates securely in place and is held down with 2 bolts, which are done up by hand. After powering up, the build plate has to be installed and levelled. For this, a sheet of card is provided, and as long as you follow the instructions, you should be golden. Then an exposure test is carried out, and it's time to print. The only problem was, I didn't have anything to print. Printing Milano was way off, for reasons I'll go into later, but I really wanted to fire this bad boy up and see what it could do. After a little surfing around, I found the perfect subject. Wicked have a fantastic range of figures available for all your favourite Marvel and movie figures. The sculpting's spot on, the poses are great, and they're full of detail. That just left my choice of what to go for. Well, it had to be Star-Lord, didn't it? This is Star-Lord from the first scene of the first Guardians movie, and features him with his guns and mask. This is the perfect figure to go with Milano. The files come with alternate heads and parts fully broken down for smaller printers or as upper and lower halves for the more adventurous. After purchasing them, I downloaded Elegoo's slicer of choice, Chitubox. This is version 2, which is a massive improvement on the previous incarnation. There is a paid version, but I just went for the basic slicer. Once you open it up, you can import your STL files and set to work preparing them for printing. The files for Star-Lord can make a massive figure, but I didn't want to go huge, so scaled the parts down to 60%, which would allow me to get all the parts on one print job. That's one of the great things about large printers, you can get so much printed in one go. I start by angling the print to get the most reliable, easiest supported orientation. I then hollow the part with a 1.2mm wall thickness. An internal lattice option is also selected. Drain holes are also added to help flush out any uncured resin from the inside. I add plenty where they can't be seen. Then it's time to add the supports, starting with the main heavy ones. Chitubox does a great job of showing where the supports are needed most. I really like this interface. It gives great feedback on what your part needs to print well, and is easy to use. With the part supported, it can then be sliced and previewed just to check everything looks good. I always make a point of saving the supported model as a separate file, so that I can add it to another print job should I need spares. With all the parts prepared, I filled the build plate, sliced and saved the file to my hard drive, and can then transfer it to the printer. It was then just a matter of powering up, plugging in the USB drive, adding the resin, and hitting go. It's always a bit nerve-wracking starting with a new printer, and unfortunately, things didn't go well. It was absolutely no fault of the printer, it was just down to where I had it. The printer is in my unheated studio, and the temperature wasn't within the curing range of the resin. As such, my first layers weren't sticking to the build plate. Once I'd worked out what was going on, I increased the exposure time for the bottom layers by 30% and also slowed the retraction speed by 30%, resliced and started again. While the second attempt was running, Elegoo kindly sent me a care package of some resin and a wash and cure station. This was a big step up for me from my bucket of IPA, UV lamp and a solar turntable. Instructions for the wash and cure unit are clear and simple. By now I had some prints that needed washing and curing. It's a really easy process. Just load up the basket, put it in the tub, pour in the IPA, set the timer and hit go. There's a whirly thing that spins around in the bottom that stirs up the IPA to get the resin off the print. Once it's washed, you just drain the print, put the turntable in place, set the timer and let it run. After a few minutes the part is nicely cured. After a session with my new yellow box, all the parts are washed and cured. But before we take a look at the prints, what's my verdict on the Jupiter SE? In the world of large resin printers, the only comparison can be with Anycubic M3 Max. Elegoo have managed to undercut Anycubic with their Jupiter SE, and to be honest, there's little to choose between the two printers. As you'll soon see, the print quality is outstanding. Both are similar in size, weight, build volume and resolution, but Elegoo have worked hard to make a lower cost product without loss of quality. This is a great value printer, and if you need a big printer on a budget, I highly recommend it. Okay, let's check out the prints. These are just with basic Elegoo resin and settings. All I changed was setting the layer height to 20 microns and the exposure time to compensate for the low temperature. Having an XY resolution of 51 microns doesn't show at all. There are no layer lines or islands on any of these prints. I think they're some of the best prints I've ever produced. Even the geometric shapes of the base show no artifacts. All it needs is the standard cleanup procedure. Nothing fancy. I cured these prints prior to removing the supports, so I could show you guys the prints intact. Now it's time to liberate the parts and see what we've got. Being hollow, the parts are really light, but given their shape and the internal lattice, They're really strong. After a thorough clean-up, the parts can be fitted together. I'll be using superglue. The fit is really good, a testimony to good design, careful setup in the slicer, and a quality printer. Let's see what Star-Lord looks like in one piece. Very impressive. It's a great sculpture and a terrific print. There's a link in the description where you can get the files for Star-Lord, and of course your own Elegoo Jupiter SE. Okay, now for Milano. With the cockpit now designed and printed, it's time to turn my design skills to the rest of this gorgeous ship. The cockpit was a real challenge, but the exterior was a whole new set of problems. I've always used Cinema 4D for my 3D modelling. It'll do way more than I'll ever need, and I'm too old to try and learn something else. As I explained in episode 1, I begin by loading plans of Milano into the top, side and front views of the software. These will give me a guide to build from. Milano is a very complex form, and to begin the main hull, I start with a simple square. This is an example of some of the techniques I use. From this basic shape I can extend the sides in any direction, and then join the points together to create a container. Points, edges and faces can then be moved to create the desired shapes. Faces can be divided and extruded in a variety of ways. Using these basic tools, I can begin to build the hull of the Milano, and after a few days, I get to something like this. Here you can see the lines and points that make up the hull. There are a lot of them, and together they make up a mesh. Openings and cutouts are also formed, as is the inner wall to give the part thickness. This is a single object, and the Milano will be made up of many more. As you can see, it's very faceted, and we only have half of the hull. Fortunately, the hull can be mirrored, and we now have a complete hull shape, perfectly symmetrical. I can do this for the whole of Milano, which will give us a perfect model. But what about the facets? Well, there's another tool called a subdivision, and here's how it works. Here's an example of a typical Milano shape. We want a curvy bulgy bit and straight edges everywhere else. If we apply a subdivision to it, everything gets smoothed out. The bulgy bit looks great, but we've lost our straight edges. To solve this, we need to add extra geometry in the way of supporting edges to the part. These are fiddly to add, but crucial to get those sharp edges back. On the Milano, these supporting edges are everywhere, another reason why progress takes so long. With the edges added, we can turn the subdivision back on and see what we've got. That's a lot better, but it's just one corner. Here's the Milano with subdivisions. You can see the resolution's gone up, and the hull looks much smoother. Crucially, there are crisp edges where they need to be, thanks to the additional geometry. This is just one part, and there are many more still to go, and this hull part isn't finished yet. So here's where I am so far. The red parts are just placeholders to give me an idea of how the basic shapes look together. They're just at the start of their journey. The more complex the part, the more geometry, and Milano is a busy bird. So far she's looking good, but there's a long way to go. I have this concept art for some inspiration, which helps a lot, although the final version of Milano is different in many ways. Screen grabs help a lot, but in some cases I'll have to get a little creative. Which takes me on to the biggest problem I have with Milano, but while I explain that, here's some renders of progress so far. It's one thing designing an object in the computer, in virtual space, but it's another thing entirely bringing it into the real world. This had been my biggest stumbling block with Milano, and taking that break helped me work out a solution to the problem. Resin 3D printers are great, but large parts can distort, and when it comes to joining large complex curves together, that's not what you want. I considered designing the parts for FDM printing, but there'd be way too much finishing work. Milano also needs a structure to support its weight and carry the 1 meter wingspan. I now have a plan, or at least a concept of how I plan to display and support Milano. Hopefully it'll work. But I have to design the exterior first, then I know where to place the structure. Once the structure's been designed, I can then begin printing the parts and bring this beautiful ship to life. I hope you've enjoyed this episode of Project Milano. If you have, please share with your friends and make sure you subscribe to my channel. So you catch my next video when it goes live, click on the bell icon. To learn about some of the techniques I use, check out my how-to series to find out more about moulding, casting, CAD design and 3D printing. If you have any questions about Project Milano, just leave them in the comments and I'll get back to you. Thanks for watching.